Okay, good afternoon or good morning, everybody. Thank you for joining me. Got you all muted, but if you do have any questions as we're going along, you can type them into the chat box at the bottom, and when we get to the end, I'll try to respond to what I can. If we end up going over an hour, I'm fine with that. If you want to drop off whenever, fine with that too. But thank you. We're going to try to do this once a month, ultimately the third Friday. And we'll cover different topics each month. So this month is basics in IGEMS, and then next month we'll get into some more advanced features of the 2D area. Probably December, talk about some of the 5-axis capabilities, and then we'll see. We'll go from there as far as the interest level. So if there's other topics you want me to cover anytime, feel free to email me, and certainly love to add it to the agenda. So the objective of these is more than just a sales pitch, to kind of do a little bit of in-depth exploration of iGEMS. Some of you have had iGEMS for a while. Some of you may have never had iGEMS and just kind of want to see what it can do. So we will kind of get a little bit into the weeds in these. So I'm not going to do like a light sales type overview. It'll be a little bit more in depth than what you might usually get. So with that, did want to give just a quick tour of WARDJet for those of you that have never been here. We're in Ohio, near Akron. We've got about 90 plus employees. We've been doing Waterjet since 2003. We've got several cameras set up here around our factories. So if you do ever come here for our training course that we offer, this would be the machine that you'd work with when we get into machine maintenance type things. So that's one camera that we've got set up here. And that one there is maybe not live right now. We'll refresh that one. This is our circuit board room. We make all of our own circuit boards for our equipment. So this is the room where those are made. And this is our welding area. So we have quite a few welders here. All the tanks for our equipment are welded here on site. And if I go over to this camera here, this one here is a view of our production bay. I'll go back to this one here. This is another view from the production bay. So this is a gantry for a large machine that we're building. We have a 50-foot long tank in it. So we've got several different machines going through the process. One of the neat things, if you ever do come to WARDJet, is 1 week, from week to week, the whole array of machines that's on the floor will change. So it's a pretty exciting place to work. These are some smaller 5x5 machines that we have coming through the process. And let's see, welding area from the other view there. And then we've got several machining centers. There's a large Giddings and Lewis mill that we have 36 foot of travel, 5-axis capability, tandem tables and such. So we have a lot of in-house manufacturing capabilities, which makes us quite unique in the industry. It's everything done here in Ohio. And we've got a VF4, VF2, and then a VF12 over there. So just want to give you all a view of that, just for those of you that have never been here before. Close those out. So if you are a current IGEMS user, when you purchased IGEMS, you would have received an email from us that had details as far as your login and password for the IGEMS website. If you don't have that, you can email me and I can email you back as far as what that is. So with that login and password, you're able to go to the IGEMS website and update your IGEMS, which I myself do almost weekly, just because of my support role. I like to always have the latest version, but probably at least quarterly. Come to the IGEMS website, log on, put in your login and password, and when you come to this screen here, this will show you the current version for which you are able to download. So as long as your maintenance is up to date, then you can always download the latest version. If your maintenance is out of date, then the version that you can download here will be older than the latest version. So one thing to be careful of is if your maintenance is out of date and you come here, always click on this one, because if you click on a newer version, then you'll be in trial mode. And we have had people who have downloaded a version for which they're not eligible for and worked for an hour or so in IGEMS, not realizing that they're in trial mode, and then they go to save it and they can't, and then they have to go back and redo all that. So that's where you go to get your updates. And then on our website, we've got under the support area, if you come down to IGEMS training, you'll come to this page here, and on here we've got a bunch of different IGEMS videos from the basics of how to download and install it, basic stuff that we'll be going through today. So you can scroll over on here and see additional videos, advanced videos for things like command line cutting, chain cutting, things like that. And then you scroll down some more and we've got some videos on 5-axis programming and things, and even some legacy tutorials for people that are still working in IGEMS R9. So a lot of information there on our website. All right, so I'll go ahead and minimize this, and I'll go ahead and start up IGEMS. So hopefully everybody's hearing me okay. So first of all, I'll talk about the infamous shared folder. So if you go to the CAD menu in IGEMS, so when we first open up IGEMS, you've got these different tabs that go across here, CAD tab, tools, and we'll go through these different tabs here. But when you first open it up, you're usually on the CAD tab. If you go to the system menu here, so you got a little sub menu. As you hover over these little buttons here, you see as it changes color, that indicates that there's a sub menu, so you can click on here. And if I click on this shared folder button here, this will open up your shared folder. So the shared folder has all the information related to your machine, things like your different machines that are available, different materials that you've got, post-processor, which controls how your machine behaves, puts out all the proper code for your equipment. So this here is very important if you are actually creating code for a machine, because it controls everything about the machine. And the one thing I wanted to talk about on the shared folder in particular is if you're just a single user, you've got a single seat of IGEMS, you'll have that shared folder, and more than likely it's going to be on your local drive on your computer, and that's all well and good, because you're always just pulling off that shared folder. Where things can get a little more complicated is if you start getting multiple IGEMS users, you buy 2-3 seats of IGEMS, you want to make sure that each of these users is pulling from the same shared folder typically, because if you do it in a situation like this where each user is working off of their own local drive and their own local shared folder, over time you can get a great divergence between the machine material databases, which could cause issues if one person's creating files for the machine and then another person and they're using a totally different database. You can get great disparity in the material database over time. So better would be, if you do get multiple users on IGEMS, that they all point to one shared folder on your network, and that way somebody changes a material, adds a material, you'll all be working off the same material database there. So that's something to keep in mind if you do get multiple users of IGEMS. So with that, I'll just get into the basics of IGEMS. So when you first install IGEMS, if you haven't installed IGEMS before, a couple things to always look at. IGEMS menu, click up here, come down to preferences, check on drawing units, make sure that length is in your preferred units, which of course we're usually working inches, but sometimes when you install this, it may be in millimeters, so just change that to inches if that's what you want. And then the other thing to look at under this preferences area is if you go to this preferences, on this general tab back here, you have this box here for unitless drawings contain, and then this may be set to metric. And then again, if most of your DXF or DWG files come in inch mode, then you would want to switch this to imperial. So this just basically tells IGEMS that when you do open up a DXF or DWG file, if it's not clearly defined in that DWG or DXF file, it'll assume that the file is using whatever you specify here. If you get files that are both inch and metric, you can set it to ask, and when you open up the file, it'll prompt you and ask you whether the file is in metric or imperial. And as you can see here, this is where you specify where you want to pull for your shared folder. So if you set this to default, that'll be on your C drive, or you can click on this button here, and then you can navigate to your preferred location on your network. So we'll be going there. Then you have other nice things in here like auto save, so you can set this to save your files every 5 or 10 minutes or whatever you like. So if something were to happen, hopefully you've got a backup going there. Ortho and Snap, you can set your default items that you want for if you're doing your snap points. We can talk about that in a bit. And then display settings. Normally when you first install IGEMS, this little box here, grid visible, is usually selected, and this is usually set to points. And what that gives you is a grid. Mine's a little bit different because I've changed it, but if you get annoyed by that grid, because sometimes it really doesn't do much for you, you can come in here and you can uncheck that. Sometimes I will use this grid if I want to get an idea of if I'm cutting a small part and I want to get it centered on the intersection of 2 of the grates on our table. If I set this to visible and I change this to lines, and I set this spacing X and Y to 4 and 4, then that would match up with the spacing of our job shop grates on our machines. And then if I'm drawing a small part, then at least I can get an idea of how it's going to center on those grates if I want to keep it from tipping into the tank and I don't want to put a tab on it. So sometimes that can be helpful. And of course, you can do other things in here, is change your color. This crosshair number, I personally like setting that to a large number, and the reason I sometimes like doing that is it makes it easy if you're selecting geometries with the long crosshair. So if I want to select those 2 circles with the long crosshair, I can find it very easy to see where I need to click to be able to select those. And then also when you first install IGEMS, this area up here will be blank. And you can add commands up here that you use a lot. So I, of course, use undo and redo a lot. And over here on this menu, so let me just delete a few of these so I can show this how this works. So if you want to add a command up here, if I want to add the undo command, I can come over here, hover over it, right click, and then I can add this button here, add quick access tools, and it'll add it up there. And then redo is underneath the system menu here, so click on this and I can right click and I can also add that up there. The other one that I always like to add is the measure tool because that's actually hidden underneath this info area here, and again you can right click and add that up to the quick access toolbar. So I'll go through and put all my common commands that I like up there. So the CAD tab here, you've got your basic 2D CAD functionality. So you can use IGEMS to draw things. And so, for example, I want to draw a rectangle. I can click on the command. Also on any of these commands, as I hover over them, you can see that that little tooltip shows up for quick commands. So on my keyboard, if I want to do a rectangle, I can just press the letter N, or I can press L for a line, C for a circle. Things like copy, Shift C for copy, things like that. You can just do very quickly just by pressing the key on your keyboard. So if I want to draw a rectangle, I can click. Down at the bottom is where IGEMS communicates with you. So right now it's prompting us to specify the first corner, and it's got a default value there of 0, 0. So ultimately, if I want it anywhere, I can just left click. And then if I want to make a rectangle that's say 12 by 6, you can just start typing numbers, and that's something that gets people the first time they start working with IGEMS. They start a command like this, and they don't necessarily know how to enter the values. You just start typing, and this dialog box will pop up. So I want to do a 12 by 6 rectangle, and since this relative box is checked, that means that these coordinates are based off of where I did my initial left click. So we've got that there. Can also do things like, so if I start a line command, and I currently down here in the lower right hand corner, I have this snap button turned on. So if you've worked with CAD, you'll be familiar with the concept of snapping points. If you haven't worked with CAD, snap points allow you to very precisely pick a certain location on a geometry. So for example, I want to draw a line. If I right click, I can see a full listing of all the different snap points that I got available. So if I have a snap point that I want to use that I don't currently have turned on by default, I can either press letter, for example, midpoint M on my keyboard, or I can click on here. And then when I hover near the midpoint of a line in this case, it'll show me where that midpoint is. and then I can draw out a line. And then the other thing, if you're not familiar with CAD, we've got Ortho button down here. So Ortho, if Ortho is turned off, I can draw this line in whatever direction I want. If I turn on Ortho, then I'm only going to go in 90-degree increments. And so if I wanted to draw a line in this direction and I wanted that to be 2 inches long, again, I can just type 2. And since I got my Ortho on, just hit enter, and it's going to go 2 inches to the right. And then you can do things up here like you've got your base, again, all basic CAD, 2D CAD function offset command. Down here at the bottom, it's prompting me for a value. I want to offset this line 1 inch, just type 1, okay, click on the line, and then move your mouse up, left click, and then you can click on it again and move it down that way. And then we can do a line, endpoint to endpoint. So I want to trim something up. Up here, I've got a trim command, or again, as I hover over that, I can do T for trim, and you can get rid of that. So very easy to draw basic 2D stuff in here. The other way that you can create geometries is through this parametric library here. So you can click on here, and it brings up a library of parametric shapes. If there's ever a shape that you think you'd like to have added to this library, you can let me know, and I can let IGEMS know, and they're pretty responsive as far as adding things like that. So we've got some customers that have customized shapes, and we can certainly look at creating customized parametric shapes for you. So basic idea on these, double click on these, and they'll bring you to a window like this, and it'll show you the different dimensions on the part, and you type in your values, and you can click on either single or multi. Multi would pop in multiple parts. Single, it's just going to drop in one part. So that's another way to create geometry. And then by and large, most people are either taking in DXF or DWG files. So to do that, you go up to your IGEMS menu up here in the top left-hand corner, and you can either do open or you can do import. And I want to take a few minutes to talk about the difference between these two. So if I do open, then I select my part, click on open. What it's going to do is open this part in an entirely new workspace. And down here in the lower right-hand corner, we have this little files icon here. If I click on this, it'll show me right now that I've got 2 files open. I've got this one here, no name 2, that I've started that has those 2 parts that I did earlier. And then this workspace here has this file that I just opened up. So open will open up your file in an entirely new workspace. And if I want to go back to the other one that I've made here, if I go back up here and I go to import, this will bring that file into the same workspace. So if I'm cutting this part out of the same material as these other parts, I can open it up and use the import command and bring it into this workspace. And then this is probably something that confuses new users to IGEMS. Import, insert text. All right, why does it want to insert text? What allows you to do is take the name of the file and basically lay that text on top of the part, and then in the next step, when we go to actually create the part, it'll use that text and assign that name to that part. So it's a easy way of assigning identifications to the part. So I'm going to say yes to this, and I'm going to put this one here. And after you left click to lock this into your workspace, down here at the bottom, it's prompting us specify height, and right now the default value is 1/4 inch. And this is going to be the height of the text that is going to go on here that we'll be able to use to name the part. So if I want to accept the default value, I can just hit enter. Again, if I want to change it, I can just type in a different number. And there's the name of that file, and you can just click anywhere inside the part, and when we go and create the part, then it's going to name this part Quick Cut. So that's the difference between import versus open, and the what exactly that insert text box is prompting you for. So I'll go ahead and import a couple other files here. So we'll take this one here. I can select multiple files. So if I know all of these files here are going to be the same material, I can just either do Shift and click or Control and click. So standard Windows selection method there. And now it'll prompt me multiple times where to put the parts and where to put the text. So again, insert text, yes, and specify point. So I'll put that one there. Specify height. I'll make this just a little bit smaller. So we'll pop that on there. And here's the next one. And this one here. And this one we actually already did, so I'm just going to escape out of that. So I've got a bunch of files here that we can work with, show you some different things. All right, let's take a look at this one first. So sometimes you might get a file from my customer, and it's got things like your borders and dimensions and things like that. Of course, you can, if you want to clean it up, you can, of course, just go through and select and delete things. And again, for those of you who haven't worked with CAD before, the selection of items works like this. So if I want to say, for example, I want to select this number 8 here. If I left click up here and I drag a box and I left click down here, it's only going to select things that are entirely within this box. So in this case, it's only going to select that number 8. So if you drag a box from left to right, it's always going to select things that are entirely within that box. However, if I click and I drag a box from right to left, it's going to select everything that's inside and crossing that box. So if I left click down here, so now it's going to select that number 8, and it also selected these entire entities because they're all joined together as one entity. So that's the way that selecting works. Left to right, it's got to be entirely within the box, and right to left, it has to be inside or crossing the box. And then if you select multiple things and you want to deselect things, you can hold down your Shift key. So Shift key is a toggle that allows you to deselect items. So that's one way that you could basically clean this up. You could just drag boxes and delete things. There are some, my undo tools over here now. I got so used to it where it was before. So there's some other ways that you can also select things. If I start my erase command, so I can just do E for erase. And down here at the bottom, it's selecting objects. If I right click, you've got these different options that you can choose from. And this quick filter one is kind of a neat one. This allows you to filter things out based on different criteria. So if you wanted to go through and just select all the circles in a drawing, all the text in a drawing, you can choose different entities like that. You can also choose things based on what layer they're on. So if I choose title block, and I click on OK and I drag a box around this, it's only going to choose the entities that are on the title block. And if I do my erase command again, E for erase, select objects, quick filter. The other thing is you can also select by color. So if I check the color box and I hit the little pull down here, it'll show you what different colors are in the drawing. So if I want to choose everything that's on the green layer or green entities, I can select those, drag a box around those, and select those. Let's see, if I click on this and I want to see what layer this is or see properties about this, click on that, click on the info button over here. So this shows me that this is on the dim layer. It's a polyline. So you can also use this to figure out if you want to select certain things, how you can do that. So that's this info button up here. That's helpful. Also shows you things like length of lines and things like that. So if I do my E command again, quick filter, and we're going to turn this off. We're going to go to the dim layer again. So that's one way that you can filter things down. If you get a drawing that's got a lot of entities and you're having difficulty cleaning it up, you can use that quick filter command. So, again, there's a lot of things in these submenus that you can get into, which we're not going to get into today. But basically, again, click on any of these. And I will mention that if you're in the middle of a command and there's an option available and you don't know what the option means, then I'll show you how you can find out more. So say, for example, this part here that I drew, that really it was supposed to be, say, twice the size. Let me just join this together first as one entity. All right. Or better yet, let's do a little dimension line here. All right, so let's say that this line here was actually supposed to be 11 inches. So we would use the scale command, which is underneath the transform, and then you can come down to scale, or you can just press S on your keyboard. All right, so I want to scale this up. So I select it, hit enter, base points. It'll just figure out where basically the center of this geometry is. So you can just hit enter. And then it prompts down here for specify new distance. And then you have all these options here, X, Y, R, U, B. What do all those things mean? If you're not familiar with what all those different options are, you can press F1 at any time, and it'll bring up a context-sensitive help dialog. And let me just drag this over once it opens up here. So that brings you to the IGEMS documentation to where that command is, and then it tells you what those different options mean. So you can either scale by X dimension, Y dimension, reference, which I'll show you here because this is a very helpful one that people use a lot, non-uniform or box scale. So the X, Y, R, U, B in that option line refer to those different options there. So if you're in the middle of a command, you don't know what it does, just press F1 and it should bring you to that area in the help documentation. So for example, R, if I press R on the keyboard, prompts to specify distance. The first distance it wants to know is, all right, what distance are we scaling based off of? So we're going to scale from here to here. And now it wants to know new distance. So I just type in what I want that distance to be. So I want that length that I just clicked on to be 11 inches, type in 11, hit enter, and now that's become 11 inches. So that's a very helpful command. Sometimes you'll get in a drawing and you might only know one dimension for sure on the drawing or a couple dimensions, and you can use one dimension to basically scale the program up appropriately based off of that. All right, so I think we've got enough things in here to work with right now. So once you've got geometries, you're generally going to go, actually, let me show you a Tools tab because this is actually quite important here. If you do take in DXF, DWG files, oftentimes they're coming from customers that aren't familiar with Waterjet cutting. They may not be trimmed up. There may be lines on top of lines, things like that. So on the CAM Tools tab, you've got options that help you find and clean up different options or different items in a part. And in a future webinar, we'll go more in depth into all the different CAM tools that are available, but most of the time you'd use the Analyze and the cleanup tool. So Analyze, click on that, can drag a box around a part, and it'll highlight with either red or yellow X's items that it sees in the part. So you've got open entities here. So this, of course I did this as a bit of an extreme example, but different openings. So red X's are usually more critical than yellow X's. If I click on one of these circles, right here we've actually got a circle on top of a circle. Normally when you click on an entity in IGEMS, it'll show up as being like a dotted line like this. If you click on an entity and it shows up solid like this, then that means there's multiples on top of each other. So again, if I click on this, it's dotted. That shows that that's just one single entity. Click on this, it's solid. So there's at least two circles right on top of each other there, and who knows, maybe more. So what you can do is, and then if you want to get rid of all these X's, because usually what you'll want to do is clean it up and do the Analyze again. So you just kind of click on one of those, either the red or the yellow X's, it'll select all of them, and then you can just either do E or delete on your keyboard to get rid of those. And then you can go to the cleanup area. So click on cleanup, and down here at the bottom, it prompts us to specify tolerance. If I leave it at the default value of 0, the only thing it's going to do is remove any duplicated items. It's not going to close up any gaps or things like that. So for this, right now, I'm just going to hit enter and select objects. I'll just drag a box around this entire part here, hit enter, and it shows me down here, there were 27 entities before, now there's 23. So if we go back to this circle here and I click on this here, now I see it's dotted, which represents I just have one circle there. But I still have these gaps here. And that's where, if you go back to cleanup, specify tolerance, if I type in a number, like for example, if I type in 0.005, it's going to close up any entities that are any openings that are 5/1000ths of an inch or smaller. So again, let me just do the Analyze again so we can see where we had some openings. So we got one in each corner there, one there, one there. Each of those are a little bit different. So if we go to, let me just get rid of those again so we can see afterwards what's left. So we go to cleanup, tolerance, 0.005. Okay, drag a box around it, hit enter. So there are 23 entities before, now there's 26. And the reason now there's more is on some of those openings, any of those openings that it healed up, it drew a little line. So in this case here, this line is going to be down here, about thousandth, a little over a thousandth of an inch long. So this is something that is so small, if you were to cut this, you probably wouldn't even notice that you've got that on there. If you go to some of these bigger openings like this opening here was basically 10 thousandths in X and Y. You might not want IGEMS to clean this up, because if you have a little diagonal there, then it might actually start showing up in your part if it gets to be too big of a gap. So looks like we've got those ones cleaned up. Again, I can do my analyze, and I've still got that one big gap there. So if I'm concerned that if I do the cleanup and I'm going to have that diagonal, I don't want it, then what I can do is I could use my CAD tools to clean this up. So I'm going to explode it. So now these are two separate entities. So you got your little X for explode command, which is also on your CAD tab here. So you can you can either use the fillet command and type in a 0, or under the modify, there's this 0 fillet command. You can click on those two lines and make that all nice now. All right, so I'm just going to do a quick analyze on the rest of these here. All right, so this one we've got a couple red X's, but that's because I've got this line here, which I do want that because we're going to talk about that here in a little bit. So that's all well and good. So I'll go ahead and get rid of those. Sometimes getting these little X's can be a little tricky. So if you do have an issue selecting it, if I drag a box from right to left, it's going to select everything, and then I can hold my shift key down, deselect the line, and then hit my delete key. All right. So let's go back on our CAM tab here. So CAM is where you're going to apply all your Waterjet stuff. We're going to tell it the machine, the material, the thickness, create our part, add our tool path, and create our CNC file. So everything basically Waterjet related is going to be on your CAM tab here. So first thing you'll usually do is click on the select button here, select your machine and material. So based on whatever machine you have, you'd have a selection of machines that you can choose from here, be it either abrasive or water only, 2D or 5-axis. So I select that, I choose my nozzle orifice combination, depending on the pump size that I have and the application that I've got, I can choose that. And then you've got your material database. So if we're going to do aluminum, can select that, and then you've got your different thicknesses available. For the material database, click on this little icon here, and this will bring up your material database. So it brings you to that one that you had selected, our 1/4-inch aluminum. And then over here, we've got a lot of information related to things like how long we want to delay for piercing, different types of piercing, stationary piercing, circular piercing. If we're doing a circular pierce, the diameter of the circular pierce, the speed that we want to do a circular pierce at. If you want to do linear piercing, which would be like wiggle piercing, it'll just move back and forth in a line versus doing a circular motion. So those are two different lead-in techniques that sometimes you might use on thicker material, so you don't have to use such a long lead-in. And then you get down into things like speed, and most important for abrasive cutting is this box here, which shows you the IGEMS calculated feed rates. And all of these feed rates are based off of machinability for that material. And your machinability, if you go to the top level of any of these materials, so if I go to the top level of aluminum, and then we go on to the general tab here, we've got this machinability field. And this tells it relative to basically steel, how fast to cut. And over here on the right, we have this little question mark button here. You click on this, and this gives you some benchmarks to use for different materials. So stainless steel, we're going to be around 82. Steel, we're around 88. Aluminum, 213. And you can adjust these numbers up and down a little bit depending on hardness of your particular material. So I've got my machinability for aluminum at 205. And if we go back to 1/4-inch aluminum, if we look at this medium feed rate right now, basically we're at 36.4. So if I go back here and I change this to say 220, and we'll see that this speed has now gone up to 39.5. So this machinability number controls those speeds. And then you've got your range of speeds from your extra rough for what would be Q1, which usually you'll probably never actually cut at. That's basically like the benchmark that's used to generate the other feed rates. And then you've got your rough for Q2, Q3, Q4, Q5. And then each of these has a high speed and a low speed. So when we're coming to a corner, we're going to slow down to the low speed. And then these next box down here, steps, that's how many lines of code that it's going to use to go from the high speed to the low speed. And then the acceleration distance, deceleration distance is the distance that it uses to get up to speed and down to speed. I usually recommend to people when they're first starting Waterjet cutting that they always go with the automatic numbers that IGEMS creates. When you get more experience, more comfortable with things, if you uncheck this automatic box, you can go through and you can override these numbers. So if you wanted more steps going into a corner, longer acceleration, deacceleration distances, you can then go through and adjust all those accordingly. If you're afraid that somebody's come in here and totally screwed something up, you can always click on default and it'll regenerate things. And when you do, there's either this, there's two different basically formulas that IGEMS uses to calculate feed rates. There's automatic, which is the more recent one, or IGEMS R9, older version of IGEMS. So depending on your experience with the different feed rates, you can click on that and then it'll reset these accordingly. If you were working on R9 and you want to migrate to 2018, you've got this import button here for importing old R9 databases, and there's a video on our website on how to do that. So that's a little bit beyond the scope of this webinar for today. So down here, you've also got information for each material as far as when you get into the nesting area, what sort of a web that you want to have around the sheet of material and what sort of distance that you want to have between your parts. So each material, each thickness, you can have a different width around the collar of the material when you're nesting, and also a different gap between the parts for the nesting, which again, nesting will be a later webinar. So that's basically how the material database looks. So we'll just say okay to that. So we've got our material, got our thickness, click on OK, and we can come up here, and next step is to click on this green create button here to create a part. This create button here is if you are doing nesting, you can create a sheet to nest your parts onto, but we're not doing that right now. We're just creating parts. So we click on the green part button here, or as you see, you can press 1 on your keyboard to start the create command. And then I can just drag a box around all of these parts and hit enter, and brings up this old dialog box here. So a lot of good stuff in here that we can go through. I won't spend the time showing you what these different things are. So name box, this if there isn't any text on the part, then it's just going to use this as the prefix, and it'll use whatever is the next number in the sequence here for the part number. If there is text on the part and this box is checked, then it's going to use the text for the part name. And then you also have the choice, this filter button here. So if, for example, let me cancel out here, actually zoom in a little bit. So for example, on this part here, we're going to have two sets of text. We got the WARDJet text, which we're actually going to etch, and then this text here, which is just the part name, which we're not going to do anything with. So if I go back to my create command, select everything, with this filter button, if I turn this on, I can basically put in a wildcard thing like 1 star, and if it finds any text starting with 1 on a part, then it'll use that. It'll know that that's supposed to be the part name and not anything else. And if I don't have any filter in there and this is red, then it'll go ahead and prompt me what text I want to use as the part name. And then as we work our way down here, I've got information. Right now I've got this auto quantity box checked. If this box is not checked, you can specify a default quantity that you want to use for the parts. So if you know you're going to be nesting them in a certain quantity you want to use, you can specify that there. I want to check this auto quantity box to explain what that is, because a lot of people don't know or understand what this is. Basically what this will do is, again, let me cancel out here, zoom in here a little bit. So you get a DXF or DWG file from something like this from your customer. And basically in here, we've got 4 parts, multiple parts that are the same. So these 2 parts are the same, and these are the same, and these 2 parts are the same. If that auto quantity box is checked, IGEMS will go through and find duplicated parts and it'll reduce the number of parts and adjust the quantities accordingly. So after we create the parts, we'll see that we're going to have 2 of these and 2 of these and 2 of these and so on. So that's what that auto quantity box is. So I've got that check there. You can specify a customer name, things like that. Geometry optimization basically tells IGEMS the width of your stream and how tight of a notch to get into. And this is supposed to keep the stream from damaging your parts. So if you have a part, for example, let me just sketch this out here quickly. Let's see here, something like this and something like this. And we come to a sharp point like this. My awesome CAD system here, and say this whole part here is like 1 inch long, and this represents my 40 thou Waterjet stream. As I'm coming down into this notch, if I don't turn geometry optimization on, it's going to go all the way down till it sees its 20 thou standoff from this point here, which means it would actually end up digging into your part. With the geometry optimization turned on, it looks at that width of the stream and then says, okay, that's as far as I can get down into that notch without actually damaging the part. So that's where it'll end up turning around. So sometimes if you have really detailed parts, you might see areas where it ends up being colored in as a part, and that's what's going on here. It's basically turning early so it doesn't damage the part. So that's what this geometry optimization is. Curve fit, if you have a part that's made up of thousands of points, curve fit will go through and minimize the number of points that are in that part, so you end up with a smaller files. And then you can choose whether you want to create the toolpath right away or not. And I'm going to go ahead and just turn that off for right now so we can do that later. Other objects allows you to basically specify if there are things in here that are open geometries that you actually want to do something with. So for example, on this part here, where we want to cut this line going from the center of this hole to the center of this hole, this is an open geometry. Normally IGEMS would assume that you don't want to cut something like that, but if you do want to cut something like that, or that you want to etch text like this, which is again open geometries, you would use that other objects button to specify that you actually want to process that. And again, we'll turn that off right now. And then down here, you can specify default qualities for inside, outside cuts and other cuts. So if I know that when I'm doing my marking or slit cutting that I want that to be a little bit slower, I can say, all right, do that as extra fine. I want my internal holes to be fine, and external is going to be medium. So right now, I'll click on this other objects button, and I'm going to just go ahead and drag a box around this one here so I get the line on the text there. And then we'll go ahead and click on OK here. So you see on that WARDJet part that had also the part numbers prompting me now. So it wants to know what's supposed to be the part name for this one, and I'll select that. So now it's made parts out of all these here. So we can go ahead and do things. So on this one here, you'll see all those duplicated parts have gone away. If I double click on this part here, it shows me that I'm supposed to do 2 of those and 2 of those and things like that. So that's what that auto quantity does. It just automatically will basically combine things and make things a little bit easier to work with. So let's take a look at this part here. So we'll have some interesting things. So we're going to do a slit cut here. We're going to do some marking here. So things like that, toolpath things start being added with this toolpath area over here. So if you just want to cut things, it's going to be the contour button. If you want to do marking, we can click on this marking button here, and we select a attribute of marking. If I click on multi, I can just drag a box around what I want to mark, hit enter, and it'll add marking to that. So marking can be done either low pressure or high pressure, with or without abrasive, and at different speeds, and then that'll control the depth of that etching or marking. And then the other thing, we're going to do a slit cut across here, which is can be done with this quick cut command. So I can click on quick cut, and in here you've got choices of whether you're going to do a slit cut or a contour cut. And in this case here, we're doing a slit cut, and then overcut basically allows it, if you're actually piercing into the material and the stream lags behind a little bit, it'll actually go back on itself to make sure you get a nice clean slit through there. So if I want to, again, I can either do multi if I have multiple ones, or if I just do single, I can just click on the end of the line that I want to start at, and that would be my slit cut. So it's going to do in this case, I'll do the marking first, and then I'll come down here, traverse down, and do that slit cut. and if I hit enter, it'll bring me back here. So that's one way that you can use that quick cut command. The other way that quick cut command can be used is if you only want to do a portion of a cut on a part. So let's say our customer was giving us a piece of material that's this width here, and they're essentially just going to want us to do the bottom cut along the bottom edge here and along the top edge here. This is another area where you can use the quick cut. And in this case, rather than doing the slit command, because slit command, it goes down the center of my toolpath, I can switch to contour, and then I can offset my stream so that my part is the appropriate size, and I can tell it whether I want to offset to the left of the part or the right based on the direction that I'm going, or no compensation. So I'm going to go tool on the left. You can specify lead in length, lead out length, things like that. And we'll go ahead and do our, just click on the single here. So if I want to start at this corner here and come over to this corner here, I can click, and you can see that it's added in that cut path there, and that red line is offset from the part to account for the width of my stream. So this line here, in this case, is going to be offset about 20 thousandths of an inch from the edge of the part. And then I want to come up here and cut across here. So again, I click near this corner. Don't have to be right on it, just near it. And then we're going to go over to this corner here. So it's going to wrap it up. Blue line is a rapid, pierces, cuts in, and does that. So those are a couple of ways that the quick cut command can be used. And then the other button up here is the contour one, which is the one that you use most of the time. So this one here, you can define what you want to use for inside lead-in lengths, outside lead-in lengths, leads that you can put on corner, and then the infamous alternative lead. So external leads, fairly self-explanatory. That's what it's going to use on the outside of the cut. Internal leads is what it's going to use on the inside of the part. Corner, if it can find a corner, it'll use that. And then if there's a hole which is too small for either of these leads to work, or any of these leads to work, then it'll use whatever is defined by the alternative lead, which usually you'll set this up to be a very short lead, so hopefully it'll be able to add a toolpath to very small holes. And then on each of these, and by the way, I usually don't recommend checking automatic. There's some scripts that we can write in the background that can automate how you add leads, but that's not quite fully developed right now. So while it's tempting to check the automatic box, I would not recommend doing that for right now. Just uncheck that and just use the leads as defined in here. So in any of these leads, you've got a little pull down box, and you can define as many different leads as you want depending on what you've got going on your machine. If you click on this little edit button here, then it'll bring you in and you can edit the different parameters for the lead. So you can give it a piercing type, which that'll be a topic for another webinar, because I could probably spend an hour just talking about those different types of leads. Things like length of lead. If you want to arc into the cut, you can specify a radius. If you want to come in at an angle, you can specify whatever angle you want to come in at. Overcut. If this blue line is your lead in and the red line is your lead out, overcut is additional distance beyond the lead in that it's going to cut. So if you're getting maybe a bit of a nib at the bottom of the part, you can cut further past and remove that with the overcut. If this is set to a negative number, it'll basically put a tab on the part. So if you've got a small part you don't want to fall into the tank. For example, I have this lead short with tab set up, so you can set the tab width to be 20, 30, 40 thousandths of an inch, whatever it takes to keep it from falling out of the material. And in this case, it would stop short, and then you just have to break it out of your material. So positive number cuts past, negative number stops short. And then you've got same information for your lead out, so you can specify lead out length and radius and angle and things like that. So if I want to shorten something up, I can change that. And then we can click on OK. And then inside one, I've got this one set up as a dynamic. The difference, there's this box here, dynamic lead, and what that is you can specify a minimum and maximum lead length that you want to use. So if you know that you need at least 1/8 of an inch long lead in order for the jet to pierce through, but you know it never has to be longer than a certain number, you can check this dynamic lead box, and when you do and click on this button here, it'll prompt you what you want to use for the minimum lead length and maximum lead length. And you can, of course, change those, and they change accordingly. And if you ever want to make a new lead, you can click on this new lead box here, and you just give it whatever name, assign your different values, and you'll have a new lead there that you can use. I've got this corner lead set up. This one here, I'm coming in at 0 degrees to the corner, leading out at 0 degrees. The alternative one, basically, air start in brief just means you're going to pierce right on the edge of the material. So especially water-only applications, a lot of people, they want pierce right on the edge. Specify an air start, it'll do that. So. Then one neat thing down here is you can save lead favorites. So you can set up different lead types for, say, thin material versus thick material. If you've got, material that you drill, or you do circular low pressure piercing, or water only, you can set up different lead types. So let me go ahead and delete one of these. So if this is now what I want to use as my default lead type for, call it thin metal or whatever, just click on this and click on save, prompt me for a name, however you want to define it. Aluminum, always fun to do here. Let's see, aluminum. All right. So then and if you want change, you just click on that, and you can change to different lead types. So that's quite nice if you are working with different materials and thicknesses and things like that. So. And then down in this area here, you've got a lot of information related to how it's going to place the leads on your part. Normally, we're going to set this to closest. It'll take the closest path going from cut to cut. Down here, add new and replace existing. So if basically it means if it sees that there is no lead on a contour, it's going to add a lead. If there's an existing lead, it'll go ahead and add a lead. So that's that one. And again, probably on a future webinar, I'll talk about what these other options are. Placement external. So normally that's set to auto, but if you've got a preference for where the outside lead can be placed, you can specify that. Same thing on inside cuts. You can specify a preferred location for lead location, or just set it to auto, and it'll take the shortest path going from cut to cut. You can also click on this little icon here, and it'll toggle through all the different options. And then normally this box here is set to connect the part, and usually collision detection would be checked, so it will try to avoid cutting over itself or cutting over where it's already cut before. So, all right, so we're going to go ahead and turn that one back on. Make sure. Let me switch this back to my dynamic that I had before. All right, and we'll do multi. So what I can do is for all these parts here, I can just select them all, hit enter, and then it'll go through and add toolpaths to all these. So put those on there. Now this one here, of course, since I already had my quick cut on there, added that, but that's okay. I can quickly add that back on there. I'll just go back to my quick command here, because we're just going to go from here to here on this one, and we're going to go from here to here. So judging by where I am, I'm saying I will go over the hour, but certainly free to hang on and watch as much of this as you like. So I could go on for days about IGEMS ultimately, but we'll pick up the pace here slightly. As I said, if you do have any questions as we're going along here, you can feel free to type them into the comments area, and we'll try to answer these here in a bit. So. All right, so we did our marking on that one. We've got these ones here. So if you ever want to change your lead position, that's another area where you use this contour button. Click back up on the contour command. And if you want to individually place leads, you can use this single command. And then wherever you click is where it will place the lead. So that's the other area that you use the contour button. Multi, it'll add leads to everything. Single allows you to individually change leads. And then typically, once you've got your leads placed, you can check things like you've got this quality button. So if I click on this, it'll show me the different cut qualities that are on a part. So this one here, this pink or magenta line going across here, that's that quick cut or the other cut that I told it I want to be fine. And then my inside cuts are set to the, extra fine on that line there, fine, the light blue on the inside cuts, and then green for the outside cut. If I ever want to change something, so for this example, this part here, I also want the outside to be fine. I can click on the part, and it'll bring up this little dialog box here, and you've got your different qualities that you can choose from. So if I want to make the entire outside cut fine, I can select that. I can click on paint, and I can just you can kind of see as I go around this corner here, there's this little band that's connecting to that outside cut. I just double click somewhere on the outside cut, and it'll change the quality for the entire cut. I can also use that paint command to change the quality on just a portion of the cut. So if there was an edge here that wasn't going to be exposed, I didn't care so much about it, I can choose a different quality. Again, I can go back to paint, and I can click 2 points. So maybe going from here to here, I want that to be rougher. And IGEMS says, okay, I know the 2 points you want to apply that to on that contour. Now, do you want it going that way or that way? So I want it to be applied that way. So once I've got that highlighted yellow, I just left click, and it'll lock it in on there. So I could do something similar up here too. So you can have a whole array of qualities on your part, and then you've got different options down here as far as selecting things. If you wanted to make the entire part a certain quality, you can just do on part, and it'll change everything. We'll talk about some of these other ones in a future webinar. So that's your quality command. These ones will be for future. Modify allows you to do things like change cut sequence on a part. So if we zoom in again on this part here, so this shows me the cut sequence in the part. So sometimes you might want to change your cut sequence. Maybe you want to do the order of the holes differently. You can come in here, you can click onto here and see the order in which IGEMS has selected to do the holes. But if I say, all right, I want this to actually be further down, I've got these arrows here, and I can change my cut sequence. So you can do what you want with your cut sequence there. The other thing that's quite nice in here is sometimes people want to leave additional stock for later machining. So they might want to leave 50 thou material or more, and then they're going to come back and machine that off. You've got this oversized box here. So if on the outside cut I wanted to leave additional material and I want to leave 50 thou per side, I can type in 0.1, and as I zoom in over here, once I click out of this box, you'll see that this line is going to move away from the part. And so it's adding 50 thou material per side. So a lot of like aerospace companies will use that because they'll generally always be machining the parts. So you can do that same thing on a hole. So this inside hole here, if I find it in my sequence here, because it's cut number 3, I can go through and change this. So in this case here, since it's inside hole, I actually want to make this one a negative number. So I would type in negative 0.1. And again, once I click out of there, you can see that tool path moved in so that this hole will be smaller. You can also do things in here, like you can change your lead-in length, things like that, if you want to change them in here. So that's the edit button. Delete button can be used to delete a cut. So if you decide that you don't want to do a particular cut, you can just use the delete command, and you can click on something and delete that tool path. So now it'll only do those 3 inside holes and then the outside. So that's your delete command. 2D 5X, 3D 5X, we'll talk about that in a future webinar. And then the next step of the process is to set the 0, point on a part, and that's where you're going to set your nozzle when you start your program. So if you just want to cut, say for example, this one part here, click on this order button and select the part, hit enter, and it's going to bring up a dialog box like this. So right now we've just got one part in this cut order, and it highlights it, and that would basically usually be it. So we're just going to hit close on that. And again, if I wanted to do this one as its own separate individual file, select that like that. Now if I want to do group parts together, let me just do a quick nest here. Again, I'll talk more about nesting in a future webinar. Don't want to get too far into the nesting right now, but if I want to nest, say, all of these parts onto this sheet of material, I can go through, and it's got quantities. I can change quantities, things like that in here. I'm just going to go ahead and click nest for right now, and it'll go through and spin those around, optimize my material, things like that. So in this case here, I want to set my cut order, click on this cut order button here, drag a box around the parts, hit enter, and based on my machine configuration, it'll set my 00 point either lower left or lower right-hand corner of the sheet. And then we've got this listing of all the different parts that are in the sheet, and you can click on here and you can see the cut sequence. Right now my sorting was set to manual, which normally I'd probably set that to closest. So you got all these different algorithms that you can use to work your way through the sheet, be it closest or zigzag. If you do zigzag and you click on sort, it'll prompt you where you want to start from. So maybe you want to start in the top left-hand corner of the sheet and you want to work vertically through the sheet in zigzag mode and click on OK, and then it'll change the cut sequence accordingly. And so you got those different options that you can choose from there. If we do closest, that'll kind of should be shortest tool path. If you do want to manually change something, you can just, again, find it in the sequence here, and you can move it up and down in your cut sequence on the sheet. One thing that may come up is you want to change where your 00 point is on a part. Let's see, let's say, for example, on this part here, we actually want to set our 00 point. The part came in and it's got this hole that's already cut out of that part. You can set your 00 point on particular geometries, and then you'd set your nozzle at the middle of that hole to cut that part. So you can use this button here to change your 0 point if you need to. So let's see, we got our nest there. So then the next step is typically click on the process button here. And then you can then select which cut order that you want to add a tool, or you want to create your CNC file for. So the process area is where you start actually creating your CNC file. So if you just want to do this part here, you would click either on the bullseye or the little rapid coming away from that bullseye, and that tells IGEMS that this is the part that you want to create your CNC file for. So then in here, there's different things you can do, like you can do either a 2D or a 3D simulation. So 3D simulation is particularly nice when you get into doing 5-axis cutting, so you can see which way that the cutting head is going to move. So over here on the left, you've got the G&M codes that we're running our machine off of. So this is nice just to be able to step through it and confirm that the machine's going to do what you think it should be doing. So it shows us things like feed rates and such. You can pause it, you can step back line by line or cut by cut. You got the little slider down here. You can speed it up, slow it down, and such. You can spin it around and things. So that's the 3D preview. A lot of times for just a 2D part like this, you can just do the 2D preview and works similar fashion. The big rectangle that you're seeing there is supposed to represent the cutting area of the machine. That long, narrow rectangle is supposed to represent the cross beam on the machine, and then that white circle basically is supposed to represent like the cutting head. So you just left click, and then you'll have a little box like this. Again, you can hit play down here, and you can go through. We'll slow that down a little bit. Hit on play, and it'll, again, we'll go through and give you a little preview showing you the code, and again, you can pause it and step forward and back through the program. So those are the different preview options. There's different reports that you can generate here. Let me go ahead and just click on this button here. This will create the CNC file. And then there's a bunch of different options that you can control the way that the machine behaves. And these are defined if I click on here under this strategy area. So there's things like where your 0 point is on your machine. If you have programmable Z, do you want the cutting head to lift between cuts and parts, and how high you want it to lift between cuts, and how high you want it to lift between parts, and whether you want to have it do that all the time or most of the time, but you might want to toggle it off, and you can turn these things on and off. So if you have programmable Z, you have a lot of ways to control things like that. You can control whether you want the pump to like turn on automatically, turn off automatically. We'll save those for, again, probably another webinar. But most of the time, click on the Save button. You can adjust your tool diameter. So you've got your nominal tool diameter, which if you know that your nozzle's worn, you can go through and you can plug in a different number. So if you know your nozzle's grown, you can adjust that. It'll offset an additional amount. And then go ahead and create your CNC file. And we can also customize the way that your post-processor behaves. So you may have seen there when I created that file, there was a little extra dialog box, which if you have IGEMS, you probably don't have this little dialog box, but we can customize the post processor if you want to be prompted for different things or you just want things to behave differently. So we can create little boxes like that depending on what you want to do. And then once you've created the CNC file, you can do a little, again, you can open up the CNC file in Notepad. So if you manually wanted to go through and change things, you could if you so desired. So of course, want to be very familiar with your G&M codes before you start doing that. Once you've generated the CNC file, you can take a look at the different reports. So again, reports can be customized. So if you want to add your company's logo to the report, or you want different fields to show up on the report, you can do that. Let me just sorry, let me do that again here. So let me drag this over. All right. Yeah, so I've customized this to put our logo on there and some different fields on there. So report that'll show the operator how long it's going to take to cut and things like that. Shows them information about the material and thickness and speeds and such. So a lot of good information on that report. It's also a nice little costing area in here. And if we do this one, you can plug in basically like what you want to charge for your machine to cover paying for the machine and overhead and paying for the operator, what you want to charge for consumables other than abrasive, what you're paying for abrasive. You can even type in cost of your material, things like that. You can allow for costs for getting material on and off the table and programming. So if you know, all right, we got minimum 30 minutes of programming time, material on and off and such, you can plug that in there. As you change those values, your numbers over here will change. So, you know, your material can be allocated either by, in this case, bounding box. It's going to be this gray rectangle there. So it's going to count all that material. If you do outer, it's going to basically take off. It's not going to account for that material there. You can do parts, and then probably a better example would be on the full nest. But those are a couple of the different reports that you can generate in there. So that's kind of the overview of the basics of IGEMS. Again, there are a lot of things that we can get into for future webinars, and if there are different things that you want us to cover, let me know. Let me just look through here, see, we've got a couple questions here. Okay, so we have a question about difference between lead-ins and lead-outs between IGEMS and WARDCam. So WARDCam is the default package that everybody gets with a WARDJet machine. WARDCam is meant to be just a very simple package that'll take a DXF file, create a CNC file. And question would be how to keep parts from falling into the tank in WARDCam. So in IGEMS, I was showing earlier how in this area here in the contour area, so if I didn't want this part to fall into the tank, I can change this lead to be outside with tab, and I have my overcut number in this case set to -40 thou, and when I add my lead onto there, we see now that there's that gap there so that that part wouldn't fall into the tank. So in IGEMS, the terminology is overcut, and you put a negative number in to put a tab. In WARDCam, let me pull that up here. Let's take, sorry, we'll take this one, I guess. All right. So WARDCam, if I go aluminum and pick a material, doesn't matter, go into my database, material database, go onto my leads tab down here. WARDCam is basically opposite in that WARDCam, the field is tab width, and you've got this number here. So if, for the outside cut, I don't want this part to fall into the tank. If I make this a positive number, then it's going to leave a gap there, and then you would just adjust that accordingly. So if you need a little bit more of a gap, you can adjust that, and then when you add the lead, then we'll see that there'll be a tab on that part there. So if I click on auto, so there's our tab. And then converse, again, opposite of IGEMS, if it's an inside cut and I want to cut past where I let in because I'm getting some nib or something at the bottom, if I put a negative number in here, then it'll cut past where I let in. So in WARDCam, negative number in the tab width field means it's going to cut past, and a positive number means it leaves a tab. IGEMS, negative number leaves a tab, positive number cuts past. So hope that helps. Well, I hope you all found this informative. If, as I mentioned very early on, there are the videos on our website. Again, support IGEMS training. Scroll down, and most of these videos under the basic area will cover what we went through today. If you've got any questions, please feel free to email us. You can email support@wardjet.com or me directly, letter J, D-A-Y, day@wardjet.com. I've probably spoken to a lot of you, but hope you've enjoyed this and have a great weekend.